Welcome to ScienceCover.com. To start, pause the video and complete the Do Now task. Let's look at the answer to the Do Now task. What variables affect how long it takes to warm a kettle of water to boiling point? The mass of the water, the initial temperature of the water, the amount of energy or heat supplied, the power of the kettle, or the surface area of the filament in contact with the water. In today's lesson, we will look at specific heat capacity. We will focus on what is meant by the specific heat capacity, how to use the specific heat capacity equation. We'll rearrange the equation, and we'll show how to work out the specific heat capacity experimentally. What is the specific heat capacity? If we heat two different materials in a flame for the same amount of time, then we could find that one will become warmer than the other. This is due to a property called the specific heat capacity. The specific heat capacity affects how much of a temperature rise heat energy can cause in a material. To compare one material to another fairly, we must use the same amount of each material. So this amount is 1 kilogram. That means we can define the specific heat capacity as the amount of energy required to produce a 1 degree Celsius temperature rise in 1 kilogram of material. So water has got a specific heat capacity of 4,200 joules per kilogram degree Celsius. This means that it will take 4,200 joules to raise the temperature of a kilogram of water by 1 degree. A high specific heat capacity tells us a substance is difficult to warm, that it requires more energy to produce a 1 degree temperature rise. Examples of materials with high specific heat capacities are water and ethanol. Lower specific heat capacity substances are much easier to warm, so they require less energy to produce a 1 degree temperature rise. So copper and silver have got low specific heat capacities. The energy is related to the temperature change by the equation energy equals the mass times the specific heat capacity times the temperature change. We can place this into the equation triangle, which will help us rearrange the equation. Firstly, if we want energy, cover up energy in the triangle, and it leaves you mass times specific heat capacity times temperature change at the bottom. Secondly, if I want to find the mass, I can cover up the mass, and that leaves me energy on the top divided by specific heat capacity and temperature change. If I want to find the specific heat capacity, then I need to take the energy and divide it by the mass times by the temperature change. And finally, if I want to find the temperature change, I can cover up temperature, and it tells me that the temperature change is the energy divided by the mass times the specific heat capacity. Now pause the video and complete task 1. Let's check our answers to task 1. The specific heat capacity is the amount of energy required to raise the temperature of 1 kilogram of material by 1 degree Celsius. The units for specific heat capacity are joule per kilogram degree Celsius. So the missing words were specific, temperature, 1 kilogram, 1 degree Celsius, and joule per kilogram degree Celsius. What is the formula for the specific heat capacity? Energy equals the mass times the specific heat capacity times by the temperature change. Complete the triangle. Energy should be on the top and then mass, specific heat capacity, and temperature change are at the bottom. Let's look at an example of how to use the equation to calculate energy. A girl heats 0.25 kilograms of water in a kettle from 20 degrees Celsius to 50 degrees Celsius. Then she switches the kettle off. If the specific heat capacity of the water is 4,200 joules per kilogram degree Celsius, how much of the energy has the kettle used? So the first thing to do is to set up the equation. So the energy, if we cover it up in the equation triangle, is the mass times the specific heat capacity times the temperature change. Now the first thing I want to do with the numbers really is to find what the temperature change is. So we're starting off at 20 degrees Celsius and we're heating the water to 50 degrees Celsius. So the temperature change is 50 minus 20, which gives me 30 degrees Celsius. Now I can substitute in the numbers in place of the letters in the equation. So the mass was 0.25, the specific heat capacity is 4,200, and the temperature change I now know is 30 degrees Celsius. When we multiply these three together, you get 31,500, and since that is a measure of energy, the units are joules. Let's look at another example. A girl heats a steel bar of mass 0.1 kilograms in a flame and measures the temperature rise from 20 degrees Celsius to 180 degrees Celsius. Calculate the energy used to produce this temperature rise when the specific heat capacity of steel is 466 joules per kilogram degrees Celsius. So again, set up the equation first of all by covering up the energy in the triangle, and it tells us it's the mass times the specific heat capacity times by the temperature change. Next, to find the temperature rise. So we started off at 20 and we've ended up at 180. So we can do 180, take away 20 to get 160 degrees Celsius as a temperature rise. Now we can substitute the numbers into the equation. So the mass was 0.1, specific heat capacity is 466, and the temperature change we've calculated at 160. And when we multiply these three together, you get 7,456 joules. Pause the video and complete task 2. Let's check our answers to task 2. Calculate the temperature change. We started off at 10 and rose to 35, so 35 minus 10 is 25 degrees Celsius. Calculate the mass of water that was heated. So that the cup and the water has a mass of 0.2 kilograms. The mass of the cup is 0.15, which means that the water's mass must have been 0.05. Calculate the energy used. So if we do mass times specific heat capacity times by temperature change, 0.05 times 4,200 times 25 is 5,250 joules. How much energy does it take to heat a tin can of mass 0.1 kilograms from 20 to 50? Tin has a specific heat capacity of 217, so you can do 0.1 times 217 times 30, and that gives you 651 joules. Let's look at an example of how to rearrange the equation. A prospector wants to work out how much gold he has. He heats his gold from 10 degrees Celsius to 260 degrees Celsius using 5,000 joules of energy. He knows the specific heat capacity of gold is 129 joules per kilogram degrees Celsius. How much gold does this prospector have? So we want to work out mass in this situation. So the first thing we need to do is to set up the equation. So we can cover up mass on the equation triangle. It leaves us energy on the top. So it's energy divided by, and then we've got specific heat capacity and temperature on the bottom. So energy divided by specific heat capacity times temperature change. Now we can work out the temperature change. So we've gone from 10 degrees Celsius to 260 degrees Celsius. So that would be a 250 degrees Celsius temperature change. We can now substitute the numbers into the equation. So the energy was 5,000, the specific heat capacity is 129, and the temperature change we calculated at 250. So the mass must be 0.155 kilograms. Let's have a look at another example. A lady heats a 0.025 kilogram diamond in a flame, which supplies 20,000 joules of thermal energy. The diamond has a specific heat capacity of 509 joules per kilogram degree Celsius. If the diamond is at 20 degrees Celsius before heating, what's the temperature at the end of heating? So we are looking for a temperature, so if we cover up the temperature change in the equation, it tells us that it's energy divided by mass times specific heat capacity. So then we can substitute in the numbers that we've got in the question for the letters. So temperature is 20,000 divided by 0.25 times by the specific heat capacity is 509. And this gives us a temperature change of 157 degrees Celsius. Now that's not the final answer because they're asking us what's the temperature at the end of the heating, and this is the temperature change. So to work out the final temperature, we can take the original temperature and then just add on the temperature change. So the original temperature was 20 degrees Celsius. We add on the temperature change of 157, and that gives us a total of 177 degrees Celsius. Now pause the video and complete task 3. Let's check our answers to task 3. How much energy does it take to heat 3 kilograms of water from 20 degrees Celsius to 60 degrees Celsius with a specific heat capacity of 4,200? So energy is the mass times specific heat capacity times the temperature change. So it's 3 times 4,200 times 40, which gives us 504,000 joules. Question 2. Water is placed into a kettle and heated from 20 to 30. The kettle uses 21,000 joules of energy. What is the mass of the water in the kettle? Take the specific heat capacity of water to be 4,200 joules per kilogram degree Celsius. So we can rearrange the equation here to get the mass. So mass is the energy divided by the specific heat capacity times the temperature change. So that's 21,000 divided by 4,200 times 10, and that gives you a mass of 0.5 kilograms. Question 3. What is the specific heat capacity of a 1 kilogram aluminium block that is heated from 20 degrees Celsius to 50 degrees Celsius by 27,000 joules of energy? So if you want the specific heat capacity, then you cover up C, and it's the energy divided by the mass times the specific heat capacity. That's going to be 27,000 divided by 1 times 30. So that gives us 900 joules per kilogram degree Celsius. A 1 kilogram copper block is heated from 23,100 joules of thermal energy. If the block starts off at 20 degrees Celsius, what temperature will it become at the end of the experiment? Take copper to have the specific heat capacity of 385. So we want the temperature change in this case. So if you cover up T, it gives you E divided by M times C. So that's 23,100 divided by 1 times 385. So that temperature change is 60 degrees Celsius. So to find the final temperature change, we just got to add that temperature change to the original temperature. So 60 plus 20, and that gives us 80 degrees Celsius. We can investigate the specific heat capacity of a material in a laboratory experiment. To find the specific heat capacity, you need to get a kilogram of the material. So we've got a kilogram block of aluminium shown in the diagram here. And it's got 2 holes drilled into it, one for the thermometer and one for the actual heater itself. So we connect the heater to the joule meter, which will measure the amount of energy going into the heater, and then you place that into the center of the block and switch it on, and you leave it for a few minutes. And the reason that we leave it for a few minutes is just to allow the heater itself to start warming up and to start warming the block up before we take any measurements. Then you measure the start temperature of the block and take a reading of what energy is recorded on the joule meter and start your stop clock. After 5 minutes, measure the final temperature of the block and the final reading on the joule meter. Now you need to compare your final readings to your start readings. So to find the change in temperature, you take the final temperature and the start temperature and subtract one from the other to get the temperature change. And we do a similar thing with the joule meter. You have a look at what energy on the joule meter is at the final reading and subtract what it was at the start to get the energy that's been used by the heater. So now we've got the energy used and we've also got the temperature change, and we know the mass of the block is 1 kilogram. So to work out the specific heat capacity, use the equation energy divided by mass times temperature change, substitute in the values that we've gathered in the experiment, and it should give us the calculated value for the specific heat capacity. Now pause the video and complete task 4. Let's check our answers to task 4. Write a method to an investigation that could successfully calculate the specific heat capacity of a 1 kilogram aluminium block. The first thing to do is to connect the heater to a joule meter. We can then place the heater inside the aluminium block and switch on the heater. Should allow the heater to warm for a few minutes. Take the start temperature of the block. Heat the block for 5 minutes and measure the amount of energy that has entered the heater. Measure the final temperature of the aluminium block. Calculate the temperature change of the block over the 5 minutes. Then use the equations C equals E divided by M times T. Substitute in the values you've gathered for E, M and T. And this will calculate the specific heat capacity.